Good morning, everyone. So, the next topic is assumptions in linearity or assumptions of linear elasticity. Okay, we will be following these assumptions in order to solve all the problems or to arrive at the concepts in this particular subject. The first assumption is the linearity assumption. This particular linearity assumption has two types, that is material linearity and then geometric linearity. Material linearity is nothing but your Hooke's law. What does Hooke's law state? Hooke's law states that stress and strain are directly proportional up to the proportional limit. There is a limit called as proportional limit beyond which it is not going to be proportional to each other. Okay, so we can therefore call material linearity as Hookean stress strain behavior or a linear relationship that is going to exist between stress and strain. Then what is geometric linearity? Geometric linearity means the deformation that is going to be produced. Say I'll call del as the deformation and followed by the strain that is going to be created is always going to be very small. Okay. The next assumption is that body is continuous. There is going to be continuous distribution of the body particles. The whole volume of the body, say this is a particular body, the whole volume of a body is considered to be filled with continuous matter without any void. Say this is a void, okay, then this body is not called as a continuous body if there is no void. Okay, void means body is not continuous. If there is a uniform distribution of particles in the entire body without any voids, then it is called as a continuous body. Then the third assumption is that body is perfectly elastic. Okay, elastic itself means it is going to be obey your Hooke's law. It obeys Hooke's law. Okay, if a body is considered to completely obey Hooke's law of elasticity, that is, there is going to be a linear relationship. This is a linear relationship that exists between stress and strain. Then your body is called as perfectly elastic. The stress components and the strain components are going to be linear with respect to each other. The fourth assumption is that the body is isotropic. Okay, so what is this isotropic? This means that if you have a particular body in any direction that you are going to assume, it can be in any direction. In any direction, the elastic properties. E means Young's modulus. So we determine the elastic property of a material by using Young's modulus. So the elastic property in a body is going to be same in all the directions. It is not going to change in any direction. That is isotropic. The fifth one is the displacement and strain that is produced in a body is small. Okay, that is nothing but your geometric linearity that we're talking about. So displacement and strain that are going to be produced are small. The displacement components of all the points in a body during deformation are very small in comparison to the original dimension. That is, say for example, you have a body. I can call this as having a dimension of length L. Then the deformation that has occurred, the displacement of the components that has occurred, let me call it as del L. So this entire length is L plus del L. If you compare del L, this is going to be extremely small when compared to your original length. Okay, and then the strain component and the rotation of the line elements are also very much smaller than 1. The strain components that are going to be produced are going to be extremely smaller than 1, something like disorder. This is what usually the strain that is going to be produced in a body is going to be. And please remember, strain does not have any units. Okay. The last assumption is body is homogeneous. Okay, this is the last assumption. Homogeneous means, say in case a body is said to be homogeneous, then the elastic properties are going to be completely same. This entire body consists of homogeneous particles. The particles do not change. The properties of the particles do not change. It consists of a single material. Then we can call the body to be homogeneous.